Okay, greetings everyone. My name is James. I come from Canada originally, and today I'm going to talk to you about incidental learning and an application of this to music education. So to interact well with our world, we need to be able to learn the regularities or the contingencies that exist in it. For instance, to anticipate for example, consequences of our actions. So often I use relatively artificial laboratory tasks for studying the mechanisms of learning. It's quite simple. On each trial, I present participants with a colored word, and their task is simply to identify the color. So for example, blue, red, green. The words in this task are actually kind of irrelevant for the task of color identification, but the manipulation is that each word is presented most often in one color. So for example, the laser doesn't work, move most often in blue. So the words are actually informative about the likely color and therefore the correct response. So the base finding within this task is that participants respond more quickly and accurately to the high contingency trials. For example, no, the laser really doesn't work. The trials like move in blue or tell in red, relative to the low contingency trials, the infrequent pairings like move in green. So this indicates that the participants have learned the regularities in the task, and these regularities have a sort of automatic influence on their behavior. Here we can see an example of that. In blue, the high contingency trials, participants respond faster to those than to the low contingency trials. Normally, I don't even tell participants about the manipulation of the regularities, and many of them do not even notice this after doing the task. But the effect is just always there, pretty much for all participants, which indicates a sort of implicit or you could say unconscious learning. On the other hand, if we give participants instructions and tell them about the manipulation and ask them to try to learn intentionally, that can, in fact, increase the size of the learning effect. Quite fascinating is how quickly this sort of learning actually does occur. For example, here you see that the effect is already present within the first 30 trials of learning of the task. So it's really quite rapid. Now I'm going to talk about an application of this sort of basic learning research to something more applied. I will just mention quickly that this is the thesis work of one of my doctoral students, Claudia Iorio, also in collaboration with my other PhD student, Yves Chaban, and one of my colleagues, Bénédicte Boulon-Charnat. The idea is to study learning of music, more specifically learning how to read music in standard notation, as you see here. Here, with this notation, the vertical position of the note on the staff indicates to the musician which note that they need to play or sing. So this is a rather important skill for music learning, but it's also hard. It normally takes quite a bit of time to learn how to look at these sorts of notes and interpret them. But we think we can do better. And to do that, we adapted what is called a musical Stroop paradigm, which I'll explain rather quickly before turning to our learning adaptation. In this task, on each trial, the participant is presented the musical staff, a note, and inside of the note, the name of a note. Their task is to ignore the actual position of the note and just respond to the note name written inside of it. So this actually creates two types of trials. I'm not sure how good everyone's sight reading is, but this is an example of a congruent trial because the meaning of the position of the note and the note name written inside of it actually match. So that's the note position for Ré, and written inside of it is indeed Ré. Here is an example of an incongruent trial where the meaning of the note position and the name written inside of it mismatch. So that's actually the note position for La, but written inside of it is Mi. So you have to not say La and instead say Mi. So there is an information conflict. But does this actually matter for performance? Well, probably not surprisingly. It depends on whether you're a musician or not. If you are a musician, you are in fact impaired. You're slower, for example, to respond to the incongruent trials. Why? After years of musical training, you just cannot help but look at the position of the note and automatically translate or read that note position. So it takes longer to overcome this bias and instead read the note's name. Of course, non-musicians don't show the same effect. For them, they're just reading some note names, and they don't actually know what the note positions mean, so there's not really a difference for them between congruent and incongruent. Well, what we actually wanted to do is quite a bit different. We wanted to help non-musicians to learn how to read the note positions with a learning task, and to do so much more quickly than the standard approach. So we actually used a learning manipulation just like what I talked about before with the words and the colors. Each note position on the top is presented much more frequently with the congruent or matching note name, and rarely with each of the incongruent note names. So the congruent trials are actually high contingency, and the incongruent ones are low contingency. This could allow non-musician participants to learn incidentally via the task that if I see a certain note position, probably the correct interpretation of that note position is, for example, Mi. So normally it takes non-musicians many semesters of training to learn to read this sort of notation in music school, but we think that this might work really in a matter of minutes, as we saw before with the word and color task. And indeed, it worked quite excellently. Here you see the results of participants in a condition that were told to deliberately try to learn the regularities in the task. And these participants were given no instructions at all. But in both cases, you can see that participants respond faster to the congruent trials in blue, also high contingency because we introduced that regularity, relative to the low contingency trials. And that's rather impressive because this training phase lasted only about 15 minutes, not several semesters of music training. But we already see a sort of automatic influence of the regularities on their performance. Afterwards, after this learning phase, we also wanted to see whether participants could more explicitly indicate the interpretation of the note positions. So basically, we showed them something like this without the note names and just asked them, which note do you think that is? Do, re, mi, fa, so, etc. Their performance at this task was not perfect. Remember, it was only 15 minutes of training, but much, much better than chance guessing, which was 1 in 7 in our case. Not too bad, I think, after just 15 minutes of training. So this is just the first step in what I hope to be a longer research program on this sort of question. The end goal is to develop a more practical application for music training in schools. And more globally, I think that many types of skills or sub-skills, like, for example, sight reading, can be learned much more rapidly than the traditional approaches used in schools, just by using some basic learning principles from cognitive psychology. And this sort of paradigm might be one of the ways forward. I think I was rather fast, but that's all for me. If you have questions.
Thank you very much. The timing was more than perfect. So I think we have time for many questions. Alain?
Thank you for this very explanatory talk. What is the latency of the learning process? I mean by latency, you say, okay, there is a higher performance in learning, but is it that the people that have been tested have kept this performance 1 month later without training, for instance?
Yeah, that's actually something we want to do as a follow-up study to see if we get, just in case some people didn't hear, the idea is to see whether the learning lasts. I think that was the question. Yes, so one thing we want to do in future studies is, one, to do more than just 15 minutes of training, for instance, several sessions, and then after variable delay, for instance, a few weeks or a few months, see whether there's still an influence on their behavior after the training. Okay. There are studies that exist like that on contingency learning, not with musical materials, but with more artificial materials like what I showed you before, and you do see transfer or a continuation of the learning longer time, but we still need to do that with our musical version of the task.
Thank you. Olivier?
No,
okay.
So
I have one quick question. With this kind of approach, how can you differentiate the ability to learn between child and adult, for example?
Yeah, so far we started out just with university participants because that's the easiest. But one of the longer-term goals is actually indeed to work with children, because normally most people, when they start learning music, it's at a much younger age. Yeah. And one thing we'll be looking to explore with that is more gamification. It's kind of a boring task that I showed you, but points and levels and stuff, to see whether it also helps early musicians to acquire. Yes, that's a goal for the future as well.
Okay, thank you.
So maybe you could tell us how you recruit those childs. I mean, how easy is it to recruit them, and where do you recruit them?
Well, we have a lot of developmental psychologists in our lab, and they have connections with schools, so we can go to the schools and recruit students that way. Or we could also think about contacting music education programs for the young kids to see whether we can improve their performance in music classes, for instance. So schools and programs like that are often interested in being involved in the scientific process.
So more or less, how many child have you been testing for these studies?
For this particular one, the actual learning phase was only 15 minutes. The whole thing was probably 20, but we could do longer for trying to, build up the learning effects with more phases of learning. But yes, it works very, very quickly. That's what's very nice about this type of procedure.
Okay. Thank you very much. Unless there are burning questions. Yes, there's one question over there.
One more question.
Yeah, hi, thank you very much. So I was wondering about the underlying brain regions or neural circuits underlying your paradigm, and whether you're combining your approach with functional MRI, for example.
Neuroscience isn't really my domain. I'm not really the person to ask about that. I'm more interested in the cognitive functions than but I could probably put you in contact with people who would know more about that than me. Sorry.
Okay, I think we can move. Thank you again.